Hi everyone, today I want to discuss about fractional bond orders. Generally, these type of fractional bond orders are exist when a compound or molecule shows the delocalization of electron, that is called resonance structure. And for this resonance structure we will get one more structure is called resonance hybrid structure. In that it shows the partial bonding. So this partial bonding, as in resonance hybrids, often leads to the fractional bond orders. So how to calculate this fractional bond order, I will explain you. So now first this statement, remember, fractional bonding as in resonance hybrid often leads to the fractional bond orders. So now I am taking one example, that is called ozone O3. This can be represented as this is called ozone structure, and its another resonance structure is represented as here one negative charge, here positive charge. Similarly here negative charge and this is a pi bonds, one lone pair and positive charge, this is a positive charge and lone pair, this is a lone pair, lone pair. These are the resonance structure, and its resonance hybrid structure is this is a resonance hybrid structure with the partial bond. This is called resonance structure. These are called resonance structure. This is called resonance hybrid structure. This is called partial negative 1. Another is partial positive charge. This is also both sides as a partial negative charge we can write. So this is a complete representation of the resonance hybrid structure. So how to calculate for this resonance structure the fractional bond order or simply bond order? So for the bond order formula is equal to total number of sigma and pi bonds between atoms which undergo resonance. Denominator total number of sigma bonds between atoms which undergo resonance or delocalization. This is a formula. Now if you consider the ozone, this is a ozone structure. So bond order for ozone can be represented as, then this is a 1, this is a 2, this is a 3. So total number of sigma bond and pi bond. One sigma bond, this is a pi bond, this is a sigma bond. So totally we have two sigma bonds plus one pi bond. How many sigma bond? Total number of bonds are 3. Sigma bond 1, sigma bond 1. Total 2 sigma bonds. Now I can write this is total number is 3 by 2. This can be represented as 1.5, otherwise 1 into 1 by 2. This is a fractional bond order for ozone. Similarly, for benzene structure we know. In this, we have pi bond, pi bond, pi bond. So, bond order for this. How many sigma and pi bonds? Count here. Now, this is a 1, 2, 3, 4, 5, 6 sigma bonds. Therefore, I can write 6 sigma bond plus how many pi bond? 1, 2, 3. Because these bonds only undergo delocalization. Don't consider this one, because now if I write here hydrogen, 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 these sigma bonds are not in the resonance structure between the atom. Only carbon atoms electrons only delocalized with the pi bond, not sigma, but that we are considering the formula. Therefore, now how many pi bonds are there? Pi bonds are 3 are there, so 3 pi bond. Now how many sigma bond? Already we know that is 6 sigma bonds. Therefore total 9 by 3, sorry 6. Then this can be represented as 3 2s are 3 3s are, therefore it is 3 by 2. So this is also 1.5 and equal to 1 into 1 by 2. In case if you take that CO3 minus 2 carbonate ion, this can be represented as C double bond O minus O minus. So for this, bond order can be calculated as bond order. How many sigma bonds are there? Now we can consider this a 1, 2, 3 sigma bond. So I can write 3 sigma bond plus 1 pi bond is there. Therefore I can write this is a 1 pi bond. And how many sigma bonds are there? 3 sigma bonds. So I can write now 3 sigma bond, total 4 by 3. So this can be written as 1 into 1 by 3. So this is the way of calculation of bond order for the molecule which undergo resonance. I hope you understood, but keep in mind where the delocalization takes place between the atom, that bonds only will be considered and the other bonds are not considered. In benzene structure clearly shown that these here there is no delocalization, therefore these bonds are not considered. Only the carbon atoms bonds are generally in delocalization, therefore these bond red color only consider, other are not considered. So like this we can calculate the bond order for any given molecule.